Good morning. We have discussed about the various options for the insulators which are to be taken in the field conditions. So, one of the important aspect is the reliability of the equipment, any high voltage equipment. So, presently we are referring to the insulation aspects. So, the reliability of the insulators which are being used in the transmission is of utmost importance, and the performance of these insulators in the field is to be considered for a long period of time. So, what are the factors or parameters which could hamper the performance of these insulators in the field? We will look into the aspects, various issues pertaining to the reliability conditions, and also we will look into some of the testing procedures or the techniques which are being employed in the laboratory conditions, particularly to evaluate these insulators, polymer, porcelain or glass insulators which could be used in the transmission system. So, we know that electrical apparatus, any apparatus, it could be any high voltage apparatus, why the failures do happen. These failures could be because of the several parameters which, or because of the influence of the performance over a period of time, particularly the life of the insulation degrades over a period of time in the field under which it is being operated. These parameters could be the electrical stresses which the insulation sees continuously over the period which is being used. So, these electrical stresses could be the normal stresses which I have mentioned here. The normal stresses is the stresses which the insulation is operating continuously under the working electrical stress, or normal stresses. Working electrical stresses could be a bit slightly different when compared to the normal working stresses. This could be the switching over or because of the stresses, changing of loads, addition or reduction of loads. So, this stresses the insulation has to withstand, and sometimes over voltages. So, over voltages we have discussed. Over voltages could be because of the lightning induced over voltages, which are known as lightning over voltages, or switching over voltages. This could be because of the switching operations of the isolators or circuit breakers, where the stresses faced by the insulation will be higher compared to the normal or the working stress. The second factor is the temperature. Because of the continuous stress, the temperature rise could be seen in the insulation. So, this temperature rise is different from the ambient temperatures. So, the insulation which should be able to withstand the temperature with which it is being working. So, apart from that, overload conditions. So, overload conditions, it could be because of the load addition of loads or the loads which are being applied at the required levels. So, this temperature also changes, the insulation should be able to withstand to this temperature. Ambient conditions, depending upon the insulation, where it could be an outdoor insulation, here the ambient conditions play a vital role. Apart from the temperature, the moisture, humidity, the contamination or a pollution, the dust, it could be industrial pollutants, chemical vapors, solar radiations and other things. So, these ambient conditions also hamper the performance of the insulation along with the electrical and the temperature which it is being stressed. So, the final is the mechanical stresses. These mechanical stresses also try to bring down the insulation level. Particular care has to be taken during transport or during the receipt and storage of the raw materials, or during manufacturing stages, during the quality control tests, during packing and loading and transportation again to the customer sites. So, during unloading and movement of the final locationing and commissioning or the erection of these equipments. So, several places these mechanical stresses have to be considered and proper measures have to be undertaken to see that the insulation or the equipment is not mechanically stressed. So, electromechanical forces sometimes due to short circuits also happen in the service. So, several of these stresses which are happening because of the mechanical have to be controlled. So, electrical stresses, temperature, ambient conditions, mechanical stresses, these parameters will influence the performance of the life of the insulation. Just a recap of the over voltages which we were discussing. So, the power system over voltages, mainly we have seen that there are temporary over voltages, switching over voltages and over voltages due to lightning. We have discussed about this. So, I would like to mention in case of temporary over voltages, typically these temporary over voltages could occur because of the faults, and here it could be or equivalent or slightly less than somewhere around 1.2 per unit. So, and the over voltages could last for few milliseconds to tens of seconds or sometimes even minutes. So, this may not be dangerous to the insulation by themselves. Here for proper protection the arrestor selection is done, and the arrestor tries to quench the over voltages which happen because of the temporary over voltages. The second is the switching over voltages. This switching over voltages, it could be because of the system switching operations, and it has been noticed here the switching over voltages could go up to 1.5 per unit to 5 per unit. This is a very point to be noted. So, this depends upon again the system voltage at which the equipment is being operated. So, these are mostly damped asymmetric sinusoids of double exponential type of waveforms. This waveform we will be discussing soon. Here the front time could be of a few tens of microseconds or milliseconds, and tail time could be few hundreds of milliseconds. So, here this generally decides the external insulation in particular to extra high voltage or ultra high voltage systems. Again here the protection is decided by the arrestor duty by which a long duration class. Again arrestor duty, arrestors are generally classified for a distribution class, class 1, class 2, class 3, class 4 depending upon the voltage rating and the current rating of the arrestors. So, the third is the over voltages could happen due to the lightning or natural lightning which could happen. This lightning, it could be because of the direct effect or indirect effect on the transmission system where could cause over voltages because of the lightning strokes, and this lightning stroke is known to contribute to equivalent or more than 50% of the system outages in particular EHV, extra high voltage and ultra high voltage systems. Here the waveform, or it could be lasting for few microseconds front time to few tens of microseconds is the tail time. So, this could be for a very short duration, and the voltage levels could be few hundred kilovolts to several tens of megavolts. These are the observed lightning over voltages in the field where and the currents during this lightning strike could be up to ranging anywhere between few kiloamps to 200 kiloamps. So, here again the line insulation or the basic line insulation is again depends and has to be looked into the equipment system for the performance of in case the lightning strikes the equipment. So, severely influences the transformer insulation here. So, lightning or a very sharp pulses could affect the transformer insulation. So, proper protection has to be done. So, this is the reason for the high voltage testings on the equipments which are used in the high voltage transmission or distribution or in the substation. The importance is the reliability of any equipment and safe operation of any equipment mainly depends on the integrity of its insulation. So, insulation is an utmost important aspect where in case of over voltages it has to perform and it has to last for the designed period. So, to verify this in the laboratory, the reliability and for the safe operation, high voltage testings are being carried out. It is mainly to see that a deliberate application of slightly higher voltage to the equipment than its normal working voltage for a specific period of time. So, high voltage tests are conducted intentionally, deliberately applying a higher voltage to the equipments above its normal working voltage. These values are generally specified by several standards, high voltage standards, and this gives us whether the withstand of the insulation or the breaking down of the insulation happens during this testing. The main purpose of the high voltage stress is to demonstrate that any apparatus has met the guaranteed specification. These guaranteed specifications of the dielectric strength are generally prescribed for the voltage level. These are agreed between the manufacturer, international standards play a role in this, and also the utilities. So, these specifications have to be met during the testing of this NA apparatus. And also these tests, high voltage tests, provide verification on the design, a determination of strength of the material, and also they will provide a guide to the development of a better equipment in case the insulation is not able to withstand for a particular equipment. So, this will definitely help to improve the equipment design for the manufacturers and also better performance in the field conditions. So, with that we will look into the philosophy or why the high voltage testing is important and what is the philosophy behind the testing of these equipments. Mainly we will be focusing about the insulator parts, that is ceramic, glass and porcelain. Any high voltage test which is conducted in the laboratory or in the field is expected to provide a reasonable equipment in the laboratory and employ a suitable procedure and which could be conducted in a reasonable time, which gives a reasonable assurance to the manufacturers, utilities that after the testing the apparatus is giving an expected satisfactory performance. So, with this intention the test is conducted. Here it could be simulated for one or both of the conditions. Sometimes the standards prescribe the worst case situations which may not happen in the field. So, the laboratory conditions could be severe. In sometimes it is an imaginary but sensible severe conditions that could ensure long life in service. So, these 2 points are very important which normally are simulated. So, for this you require a laboratory where internationally the recognized for the high voltage testings. The quality of any high voltage laboratory is generally assessed by the equipments which are being used. The repeatability point to be considered. Repeatability is again the main, it is the ability of any test to produce the same, that is a reasonable results every time in the laboratory. So, the equipment which is being used in any laboratory, so for a testing which is being conducted, it should be able to produce a reasonable results every time when it is being repeated. So, reproducibility is the second point to be considered. Here the reproducibility mentions the ability to produce same or reasonable results every time in any lab. So, there is a difference. The first repeatability is in the same lab, the reproducibility is to see that results are achieved whenever it is conducted in any recognized lab of internationally equivalent standards which the lab is being set up. So, the third is a representativity. This representativity is a ability of a laboratory where it could produce or it could duplicate the service or field conditions. So, we have a very few laboratories in the world where the representativity or the actual service conditions of the equipment could be simulated. So, here very important. So, the quality of any laboratory testing for the equipments is assessed by these 3 important factors: repeatability, reproducibility and the representativity of the laboratories. So, coming down to the various techniques which are generally employed, we will be focusing on the insulation aspects, as the present discussion is about the insulators, a solid type of insulators, where we were discussing about the ceramic or porcelain, glass and polymer. So, the testing techniques will be discussed pertaining to these insulations. So, we have 2 categories in the high voltage testing techniques. One is the non-destructive testing for the materials and electrical apparatus. Second is the electrical testing or the high voltage testing, which we will be discussing. So, in the non-destructive testing, here basically the insulating or dielectric materials are which are used to provide insulation for various electrical apparatus. It could be a solid, a liquid or a gas or even a combination of this. So, these insulations will be tested and these materials which are being used should possess good insulating properties over a wide range of operating parameters, particularly with regard to the temperature of operation, the frequency range, etc. So, the quality of this insulation which is used in high voltage apparatus is generally assessed by measuring the properties of these materials, solid, liquid or gases, or a combination of these materials by measuring the resistivity of a material, the dielectric constant, loss factor, what we know was the tan delta capacitance and tan delta measurements, the partial discharge testings, internal discharges which could happen in the materials, and also to find out any defect or any deterioration could be available. So, these are few of the things which are generally carried out for the material aspects known as the non-destructive testing of materials, and is been conducted in any laboratory or at the manufacturer place to assess the properties of the materials. So, the parameters which could affect the insulation resistance, as mentioned earlier, it is again depending upon the nature of materials which are being used for the insulation, at the temperature with which it is being operated. The changes in temperature could also influence the contaminants or the pollutants which could form on the surface over a period of time. So, could cause the insulation degradation with the electrical stress and the temperature. So, the voltage stress, which is continuous stress applied over a period of time till the operation of the equipment which is designed for, and the environmental factor like the humidity, the change in humidity could also affect the insulation resistance, the frequency of the equipment which is being operated, and the time of application of voltage. The time of application, it could be again the equipment specific, where like a transformer it is continuously applied. So, where it is continuously stressed, electrical stress is continuously for years to years. So, this are the parameters which could affect the insulation resistance. The second part we discussed about the non-destructive tests which are carried out for the insulation. The second important is the high voltage testing of electrical apparatus. So, as we know that in service insulation has to withstand, insulation again I mean it could be solid, liquid or a gas, we are referring to the solid insulation, has to withstand in addition to the continuous normal working voltages, higher voltages. We mentioned this, higher voltages could be because of the power frequency over voltages at the working level, where it could last few milliseconds, or the lightning over voltages which last for few tenths of microseconds, and switching surges or voltages which could relatively last for a few hundreds of microseconds. So, these over voltages are invariably caused by lightning or switching operations of the equipment, circuit breakers or isolators, In addition to these lightning and switching surges, we have discussed the power frequency over voltages above the maximum normal maximum voltages. These are basically discussed as temporary, dynamic, and are generally not very dangerous for the long run, as the insulation is considered or designed to withstand these voltages. So, insulation deterioration with time, that is aging, what we call aging or long duration period where the insulation is stressed for electrical thermal continuously in the field, even at working stresses, would degrade in case of the insulation. There is degradation because of the partial discharges due to treeing or tracking, which could lead to the failure of insulation. So, design important is hence the design of any insulation must be preceded by a critical assessment or testing for over voltages which it has to face in service, both lightning and switching surges. These have to be confirmed by the proof testing in the laboratory. The proof testing could be a prototype or a full scale model under worst simulated conditions, particularly for over voltages and also for contamination studies or the pollution studies, which we have stressed. This is a very important for extra high voltage and ultra high voltage, where apart from the lightning and over voltage switching over voltages, pollution or contamination, flashover or withstand is also one of the important design factor which we have mentioned. So, what are the high voltage tests? Now, we limit our discussion to the insulators, solid insulators. So, what type of high voltage tests are carried out in the laboratory and how we are simulating this in the laboratory. So, high voltage tests, as mentioned, is to simulate the conditions more severe than the temporary voltages. For this you have to have equipment to generate temporary higher voltages. So, to simulate temporary higher voltages, we use cascade transformers for generation of high AC voltages, and also for the measurement we use standard dividers, or we use the peak voltmeters, we use the spear gap arrangements. These things are generally discussed in high voltage engineering. So, we will limit our discussion to the testing aspects and how the waveforms are being used. So, to simulate the switching surges or switching over voltages, there is a standard wave shape which is 250 microsecond is the front time and 2500 microsecond is the tail time. So, this is a unidirectional double exponential wave shape. You can see here this is a unidirectional double exponential waveform. So, the front time which is defined here in this period is 250 microsecond, and time to tail, that is a 50% of the magnitude which is mentioned here, time to tail, this period is 2500 microseconds. So, the front time 250 microsecond, 2500 is the tail time. So, this type of waveform is impinged on the equipment, and there is a standard which mentions the number of applications on the equipment. Equipment has to withstand for this. Sometimes oscillatory type of wave shapes are also employed. These are not yet standardized. All these switching, lightning or oscillatory type of waveforms can be generated by using a Marx generator. Generally Marx generator is used where a set of capacitors are charged in parallel, and they are charged in discharged in series. So, where you get a double exponential waveform by suitably adjusting the front and tail resistors, the waveform can be achieved. So, this is obtained and suitable measurements are being used to check the magnitude of the waveform and also the front and tail time respectively. For simulating the lightning surges, here again we use the Marx generator, a similar principle. The only front and tail resistors are suitably adjusted to get the waveform of the double exponential here. Here the standard waveform is the front time being 1.2 microseconds and the tail time being 50 microseconds. Again here in case of oscillations, there are the standards prescribes whether we have to consider the 90% or it should be the 30 to 90% with a multiplication suitable multiplication factor. In case there are no initial oscillations, so the peak of this 90% into 1.25 could be considered as the front time, and the tail is considered 50% of the magnitude is given as a tail. So this is how it happens, and it is given in the standard for the calculation of both the front and tail at respective positions. So we use Marx generator here, a similar setup for a switching search. For HVDC applications, again HVDC we have a general half wave rectifier for generation of high voltage DC, or voltage doubler circuits are used. Here you have two types of voltage doubler circuits. Then for a very large high voltages you use a voltage multiplier circuit, and these voltage multiplier circuits you generate a very high voltages in terms of hundreds of kV, where or these voltages are used for the testings or the design verification of the equipment for the high voltage DC aspects. So general tests which are being conducted in the lab for the insulation are the voltage withstands test. Again the voltage withstand, it is the AC voltage, or it could be the DC voltage withstand where the equipment is of DC or the insulation is of DC. Impulse is again the surges for both lightning and switching. This lightning and switching surges are generally carried out for two conditions, that is the dry and wet conditions. The dry conditions, the specified values for a particular voltage levels are given, and the wet conditions you simulate using a nozzle set. An artificial rain nozzles are used to simulate the rain conditions, and the switching surges or the lightning surges are applied, or the AC voltage or the DC voltage is applied, and whether they will be able to withstand or the flashover of these are studied. Sometimes the combined voltage tests are also to be carried out. Here this has to simulate the conditions in the field, like any equipment which is applied with the AC stress. In case there is a strike, lightning strike, that is an impulse, so how the performance happens. So this is again simulated in the laboratory, where a combined test like continuous operating voltage of the say AC is applied to the equipment, and an impulse, known impulse for that particular voltage is applied. Here both dry and wet conditions, the equipment performance is monitored or tested to check the insulation integrity. So this is voltage withstand, whether the equipment will be able to withstand for dry wet conditions for AC, DC impulse, lightning switching surges. The second is the flashover voltage. So flashover voltage or disruptive discharge to determine the flashover strength of this insulation. Again here test like AC for the rated voltage, which the values are determined by the standards are applied. Again the impulse again the lightning, dry conditions, switching dry and wet conditions, all are very important, are generally applied, and the flashover, because or the withstand for flashover for lightning and switching both dry and wet conditions are monitored. And apart from this, in the laboratory the above tests when they are carrying out, the mounting of the object, the clearances which are to be maintained are specified, and these are to be adopted for the correctness of the testing. So several that was about the testings which are to be carried out. So when we look into the generally for the equipments, various tests are to be carried out at the manufacturing stage, industry level, the laboratory aspects, and also it involves several tests. So, this classification of high voltage tests are done like the type tests, the sample or acceptance tests. The third is the routine test, and few are also other special tests which are required for a particular equipment. So, these classified tests are performed depending upon to check the verification of the design characteristics and also the withstand level. The type tests are generally performed to verify the main design characteristics, and these type tests are generally done on a small number of samples, and these are done only once. In case the design of that equipment or the product is changed, then the type test has to be repeated. So, what are the type tests which are generally done for the insulation? So, here the insulators which we are discussing have to undergo the following type tests: electromechanical test, mechanical failing load test, thermal mechanical test, dry lightning impulse, wet power frequency, visible discharge or corona test, then physical verification of the damage. These are all the tests which comes in type test. So, the samples, few samples from the lot manufactured are selected, and these tests are generally carried out at the third party laboratories or recognized laboratories, and with the understanding between the manufacturer and the utilities. The sample test, here again the sample test is main intention is to verify the characteristics of a insulator that can vary with manufacturing process. So, here for the sample test, generally the insulators are taken at random from a lot. So, the one the manufacturer, it is few samples are selected from that particular lot, where these samples undergo the puncture withstand test, the porosity test, whether the material has a porous during the manufacturing stage, galvanizing test, thermal shock, whether the equipment will be able to or the insulator will be able to take the thermal shock. All this are prescribed in the standards, and the values or the magnitudes are also mentioned. The temperature cycle test, verification of the displacement, verification of locking systems, dimensions. So, several of these tests are carried out at a random way, choosing samples from the lot in the factory or sometimes in the laboratories. Routine tests, these routine tests are generally performed on each and every insulator samples. So, these tests are performed in the factory, and it is mainly intended to see and eliminate the defective insulator during manufacturing process prior to the crating and shipment to the utility centers. So, what are the routine tests which are supposed to undergo for each and every unit of the insulators? It could be glass, ceramic or the polymer type. There are few tests which are different from these for polymer. So, tests involve mechanical, electrical and also visual inspection which are defined. So, as I mentioned, the fourth category is other special tests. Again, this has come up because of the recent trends in testing for the service performance. So, there was a demand for this test because of increase in the demand for power. The transmission voltages have increased and also the increase in cost. So, there should be a factor of safety before the design is used or the equipment is used in the field, and with looking into the minimization of risk of failures, factor of safety with improved quality and the reliability being importance in service or a prime concern. So, these special tests are designed to achieve service reliability by the manufacturers or utilities generally carry out the following tests. These are specified for the EHV or the ultra high voltage range. See, long term reliability tests, accelerated aging test. So, main intention is to find how long the insulation could withstand when the stresses which are multi stresses which are being seen on the sample could withstand, and whether this gives an indication for the life of the insulation. The contamination or a pollution test, which was introduced later after the extra high voltage or ultra high voltage ranges, the power arc test, radio interference voltage measurements, the corona test, voltage distribution across the string of ceramic or glass insulators, switching surge, power frequency, fatigue test. So, these are all the tests have come up after the voltage levels which are being used for extra high voltage and ultra high voltage, to take special care and to see the safety and also to see the risk of failures, minimize the risk of failures. These tests have been included, which are essentially carried out for the equipments used for extra high voltage and ultra high voltage ranges. So, looking we will discuss about the importance of some of the testing here. So, thermal mechanical performance, here this thermal mechanical performance is mainly performed to ensure there is no movement of hardware, particularly the cap and pin for the insulator. There should not be any movement, as a hardware is coated with bituminous layer to prevent corrosion when in contact with the cement. So, the equipment in use should not weaken, that is the intention to conduct the temperature and mechanical performance or thermal mechanical test. This is generally an accelerated test or a long term test to determine capacity of any insulator, glass or porcelain insulator, to withstand service conditions over a specified period of time. This specified period of time is based on the standards, the manufacturers and the utilities. So, general procedure for this thermal mechanical test is to see that insulators are kept at the tension mode for 60 to 65% of the specified electrical mechanical load which are to be used, and this is subjected to a temperature variations between 35 to 40 degrees for about 96 to 100 hours. This is the procedure which is being followed to check the thermal performance of this insulator string. The second is the residual strength test. Here the insulator sheds are broken. When insulator sheds are broken, either this could be because of the vandalism or because of the damages which are seen. Here it is essential that sufficient mechanical strength should be retained in the power line, which should not come down, or it should not detach from the conductor should not detach from the tower. So, to check this performance, the strength, residual strength, the insulator sheds are intentionally broken in the and the mechanical tensile load is applied. So, whatever the load which is from the conductors, from the hardware, and also the load which is applied for the broken insulators should be able to withstand. So, this residual strength gives in case physically some due to vandalism the insulator sheds are broken, it should be able to withstand for a period of time. The third pollution test, this we have already discussed the importance of pollution induced flashover, why it happens at working voltages. So, here again what are the influencing parameters we have discussed, and the phenomena, how difficult it is to theoretically comprehend, and also how difficult it is to simulate the experimentation. We have tried to discuss about this. These tests are also essential for extra high voltage and ultra high voltage insulators, ceramic and glass insulators. For polymer, a new type of insulators which are being used, these standards are not yet finalized. So, we are discussing here for ceramic or glass. This is a general arrangement where two types of methods are employed as per the IEC 507 or 60507. One is a salt fog, other is the clean fog or a solid layer method. These are described in this standard and is been come out of this is the outcome of the several research and standard organizations like IEC, IEEE, ANSI and SIGGRAPH working groups, which they have worked for more than 50 years, and they have come up with 2 procedures for ceramic or glass insulators. So, basically the procedure involves initially the insulators have to be cleaned, then prepare a pollution slurry as per the standards. This slurry is to be applied to the test object, and the surface of this is to be checked with the equipment to uniform whether coating is done on the insulator or not. In case the uniform coating is not achieved, then again the procedure has to be repeated. If it is yes, then the wetting rate of the fog is set. The fog, it could be a cold fog or the steam fog, to make the insulator surface wet, and the high voltage is applied and the tests, the pollution tests are performed. So, this is the flow chart which describes the method adopted for the laboratory conditions. So, these are the procedures where the insulators are dried for a period of time. The experiments are conducted either with the steam fog or the cold fog conditions. So, some of the experiments conducted at the laboratory for various polluted conditions shows the flashover of the disc, the scintillations which are from the polluted insulators depending upon the applied voltages. As the voltage level increase, we can see the scintillations or the partial arcs increasing and further the flashover happening. So, this is the phenomena which happens in the similar to the field conditions. So, we will stop here and continue the testing aspects. Thank you.